In this lesson video, we are going to discuss about the basics of how to work with camera objects. As I mentioned earlier, you need a camera object if you want to perform final rendering in Blender. Okay, so what is exactly a camera object? Well, just like in the real world, the camera object in Blender is used to direct the view, so Blender knows what to display when doing the final rendering. You can also animate the camera object to add more dynamics to your animation. If we create a new default scene in Blender, we actually already have a camera object, which is this pyramid-like object with a triangle head on top of it. There are three methods that we can use to switch the 3D viewport from the user view to the camera view back and forth. The first method is by pressing 0 on the numpad. As you can see, we are now viewing the scene from the camera object. To go back to the user view mode, you can press 0 again on the numpad, okay? Now, while you are inside the camera view mode, you can see a dark area surrounding a rectangular frame. When you do final rendering, only the area inside this frame will get rendered. Anything outside the frame or in the dark areas will be ignored. While in this view, you can pan or zoom the viewport, but you cannot rotate the viewport because it will bring you back to the user view. So I repeat, you can hold Shift and drag the middle mouse button to pan the viewport around. You can also use the mouse scroll wheel or use the Control plus middle mouse button to zoom in and out of the view. But if you try to rotate the view by dragging the middle mouse button, then this will bring you back to the user view mode, okay? The second method to access the camera view mode is by clicking on this button here. Now before in Blender 2.8, this button was located around here, stacked horizontally. But since version 2.81, they moved the button to this location in vertical order. This button works like a toggle button, meaning if you click again on it, the viewport will revert back to the previous user view mode. The last method is by using the menu. To access the camera view mode, you can go to the view menu in a 3D viewport header, then choose cameras, and then choose active camera in here. Or you can also go to the viewpoint submenu here, and then choose camera in here. Yes, I know this is redundant. We have two commands in the menu that do exactly the same thing. But this is what I have in my current version of Blender, and this might be subject to change in a future release. In Blender, we can have multiple cameras in one scene. To create a new camera, simply hit Shift-A and then choose camera in here. A new camera will be created in the 3D cursor location, and it will be oriented to our current viewing angle. We can see it is pointing that way. If you want to reset the orientation of a camera object, or any object in Blender actually, you can do so by pressing Alt-R. Or if you forget the shortcut, you can go to the object menu, then clear, and then choose rotation in here. Notice if we reset the orientation, the camera will face straight down along the z-axis like this, and the triangle head will face towards the positive y-axis. Now you might be wondering, what is the function of this triangle shape? Well, this triangle's function is to indicate the local up direction of the camera object. So this is the up direction when we view the scene using this camera, okay? Now if we press 0 again, notice that we are viewing the scene from the first camera, not from the second camera that we have just created. Why is that? Well, this is because the first camera is still the active camera. You can have so many cameras in the scene, but there can only be one active camera. We can tell which one is the active camera visually by looking at the color of the triangle head. The active camera will have a solid color triangle like this one, while the non-active cameras have the triangle hollow or only showing the lines like this one. In the outliner, we can tell which one is the active camera by looking at this icon in here. The one with bright background is the active camera. Okay, now what if we want to make this camera as the active camera? Well, we can do this in three different ways. First, by using the keyboard shortcut. But first, we need to make sure that the camera is selected, and then press Ctrl 0. The camera now is the active camera, And the viewport also changed to the camera view automatically. We can see that in the outliner, the icon now has brighter background color. And also, if we rotate the viewport, we can see this camera now have a solid triangle head on top of it. The second method is by going to the View menu, then Cameras, and then choose Set Active Object as Camera in here. And the last method is by going to the outliner and just click on this small camera icon. The next technique we are going to discuss in this lesson is aligning the active camera to the current user view. Let's say we are in the user view mode, and after rotating the view and adjusting the zoom, we happen to like the view angle, and we want to use that view for the final rendering. Remember, final rendering needs a camera, and right now we are viewing the scene in the user view mode, not in the camera view mode. So essentially, we want to make the active camera to reposition and align itself to our current user view. To do that, we can hold Ctrl, Alt, and then press 0. Or if you forget the shortcut, you can go to the View menu, then Align View, and then choose this command, Align Active Camera to View. As you can see, now the active camera has changed, and it is now viewing the scene just like how we see the scene before in the user view mode. If we have a camera object selected, in the Properties editor, we can see a Camera tab. Here, we can see a bunch of parameters that we can tweak. For now, we will cover only the most important ones. At the top area, we can set the camera mode to be perspective, orthographic, or panoramic. We have discussed about perspective and orthographic before, but just for a quick reminder, perspective will have vanishing points, just like how we see 3D objects in the real world, while orthographic, or also known as isometric, will display the 3D scene without any vanishing points. This is useful if you want to create isometric game artworks or icons, etc. Panoramic option in here will create a 360-degree render that is useful for creating sky backgrounds for game engines, for example, or for creating high dynamic range images. Currently in my version of Blender, panoramic mode is not supported by Eevee rendering engine. You need to use cycles for this, but we are not going to cover panoramic rendering in this lesson. Let's focus on the perspective mode, as mostly this is the mode you will be using when doing the final rendering. The next parameter, which I believe the most important one, is the focal length in here. By default, it uses millimeter measurement unit, equivalent to the real-world camera lenses. For those of you not familiar with camera's focal length value, essentially this parameter controls the width of the camera view angle. The smaller the focal length value, the wider the view, thus making the perspective distortion very strong. The larger the focal length value, the narrower the viewing angle, thus making the perspective distortion less noticeable. If you don't like to use camera's focal length value and just want to control the viewing angle directly using a degree value, you can do so by using this field of view parameter. Again, the function is similar to the focal length value, which essentially controls the width of the camera view, but it uses angle degrees instead of lens millimeter value. The shift value here is useful for shifting the camera view from its original position. The X value will shift the camera horizontally, and the Y value will shift the camera vertically. This is mostly useful for creating camera vertical shift effect, which is usually needed for architectural rendering. But this will be an advanced topic, so we will have to skip it for now. Next is the clipping values. These values are useful to hide objects that are too close or too far away from the camera. Essentially, the camera will only render objects that are located between the start and the end values. Notice if we drag this start value up, at a certain point, some parts of the cube will be clipped out from the rendering. Usually, I just set this start value very low, like 0.01, okay?